Hello and welcome back to Steam with Steve. Today we're going to go through a really cool library called the Turtle Graphics Library in Python. Now this library allows you to draw a whole heap of different images and make some really complex shapes inside of Python, which is a lot of fun and a really good way of introducing how graphics works. So let's jump on in. So the things that we're going to cover today, basically we're going to understand how the Python Turtle library works, learn how the control structures in Python work, including selection, sequence, and repetition, recognize the importance of using libraries and comments inside of Python, and then explore some practical applications of Python in various fields. So to start, a little bit of history about where this Turtle graphics came from. It actually was an original programming language called Logo, and what it does is it allows you to draw some really complex shapes, as complex as you can sort of imagine, and basically the little turtle moves around and drops the line behind him as he goes. So you'll have a whole heap of different commands, such as turning forward, moving left, and then also you can control when the pen is down and when the pen is up. So we're going to go through some of the basics with how this all sort of works, including how to build the turtle to start, which is a lot of fun. So to start, what I've got is this exercise here where I just want you guys to copy it and have a run of it. So just pause the video, open up Python idle, and then create a new file, and then build that code. Awesome. Hopefully you've had a good go at it. I'm going to have a go as well just to show you how it sort of all comes together. So if we open up idle, what I meant by creating a new file, so instead of typing in the whole bit of code in there in the interpreter, what we can do is create a script, which is what this new file is going to be doing. What we're going to do is we're just going to follow along and build the code. Okie. So to start, at the very top, we've got import. What that does is it imports the whole of the turtle library. So we're going to import turtle. Start. From that, we're then going to set the colors. Now what this is a comment, so they change to red. We're going to set the colors, and then we're going to go, the colors are now equal to either red, orange, yellow, green, blue, or purple. Then we're going to set the background of the graphics that's going to be displayed to black. So that's what BG means. So background, color, and we're just going to set it to black. Now I'm not expecting to understand all this code. We're just basically copying it. And then we get to see the cool result of it. So then we're going to then create a turtle. And I'm going to call my turtle Leo. I love Ninja Turtles. So turtle.turtle. And then Leo.hide the turtle. So that you can't see the turtle as it's building. And Leo.speed 0 means the turtle goes as fast as it can. We're then going to create the image. And I'm going to go for X in range 300 colon Leo.pen color colors square bracket X mod 6. So that's going to choose a random color based off the position that it's currently up to. And then Leo.width X divided by 100 plus 1. Leo.forward X. Leo.left 59. Cool. So now we're going to save that. Movement. Important, don't call it turtle, otherwise it won't run. And then we run the module. And off it goes. So what it does is it makes this cool little spiral pattern, goes on as long as the loop was. And what you can see is it's changing the color on the edge each time, and then slowly rotating around the edge and just drawing straight lines to make this really cool pattern, which is a bit of fun, something a bit gimmicky, but it's a cool way of seeing what you can do inside of this library. And there's more to come as we sort of progress. So you won't expect to know exactly how to do all that, just copy and paste it. But hopefully you picked up some cool things that can happen in there. So we're going to tie over these control structures that we see again. We actually just did another one then where we did repetition. So sequence is when you have a series of events, which is what all of our programs have been. Selection, which we haven't quite done yet, is where you've got a choice. So you can either go this way or this way. And lastly, got repetition, where a condition will keep going until it basically ends, which is what you just saw in that little loop demonstration. So what does a library mean when we're talking about this turtle library? Well, a library is old school, if we think about it, as a building that stores a whole heap of books. And the idea behind that in Python is the library allows you to use code that other people have written. So rather than reinventing the wheel, someone else has gone off and built the total library. So instead of you having to type it all out again, you just have to import that total library, which is really, really cool. So this saves us a lot of time as a good programmer. So we save time by basically getting these libraries and integrating them into our code, which is pretty cool. And the way that you do that, it's really simple. You just use the import command term. So that's one of those reserve words we talked about, and that's pretty much it. So in small little groups, can you just have a quick little chat? How could Python be used in the real world? So just pause the video there and have a chat. Have a bit of a think. Awesome. So there's a whole heap of different ways that Python can be used. So here's some that I've come up with. So there's web development. You can do game development. You can do machine learning and artificial intelligence, which is one of those huge areas that has taken off, with data science and data visualization as well. And then you can do all your desktop graphical user interface stuff as well, which is pretty cool. So there's a whole heap of business applications that are happening. Microsoft Excel is actually swapping over to using Python now as its main library, which is really, really useful. And then you've got a whole heap of audio and visual video applications that you can do. And then also computer-aided drafting or CAD applications. So there's a whole heap of different things that Python can be used inside of business applications. So here's a bit of a bad joke. So a journalist asked a programmer, what makes code bad? No comment. And that's so true. With your code that you're going to put together, if you don't put comments in it, it becomes really, really bad. And it's hard for other people to read. So what is a comment? Well, we just did it before in that little example before. Comments are anything with a hash, and it will make the interpreter change red inside of idle. So the idea behind this is that it gives you some sort of structure that the programmer can read and understand what you're trying to do, but then the computer program doesn't actually run. So it basically makes you skip that line when it's going through the interpreter. So comments are used to make the code a whole heap easier to read and understand. It's a delicate balance though, so you want to make sure that the code is readable, but it's also got to be functional. So this is what we know as refactoring, where we go through and try and adjust the code. In Python, we simply type the hash character before the string of text, and then that makes a comment. And then it will change the code to red, which means that that line of code will not be executed. So it's just going to be skipped, which is really, really, really cool. Good programmers make sure that their code is easy to read, so then the next person reading it can understand what's going on. So why do we want to use comments? Here's a bit of a funny joke. Always code as if as if whoever ends up maintaining your code will be a violent psychopath who knows where you live, right? So you need to make sure that someone picking up your code will not be upset with you when you once you've finished. So the big difference between an interpreter and compiler. So an interpreter, like I said before, is like a conversation. So they convert one statement at a time, and it's really good for simple programs and also all the Python scripts that we're doing. When we do compiling, it's like making a book. So it converts all the statements down to the zeros and ones. And this is really good for complex programs. So something like a video game or a high level application like Premiere Pro would have to be compiled, not interpreted. So interpreters are faster to type together and quickly run, but they don't allow for more complex things to happen and don't run as fast. So how do we access the compiler in Python? So this isn't exactly the compiler, which you saw before. It's basically where you open up a new file. So inside of Python in the shell, at the top, you'll see file. You can then click on the file, then click on new file, and then save it in the proper location. So like what we just did before with the original artwork, basically the idea behind this then saves you a whole heap of time because you just open up that script and you can change the code there. So the Python turtle library, what will happen when you start is it basically just creates a little black turtle on the center of the screen, and then you're able to move it around and do some different things with it. So there's a good video here which I'd recommend. I've put a link in below. Yeah, so I personally like calling my turtle Leo, just because I'm a Ninja Turtle fan. It makes my life a little bit easier and gives it a bit of funniness when I'm sort of coding. You can choose whatever you would like, but I recommend making sure it's something a bit more memorable for you. So to make the turtle move around, we've got 4 commands we're going to start off with. So we're going to do forwards, backwards, left, and right. So forwards move a certain amount of pixels. So pixels are how many dots are on your screen. And then left and right then changes the degrees. So it turns the angular distance. So the standard code to create a turtle is this. So you literally go import turtle. Leo is equal to turtle.turtle. Leo.shape is a turtle. And Leo.color is blue. So I'm going to do that again. Here now, movement code. And I'm going to put this over this side. And let's change this up. So I'm going to get rid of that. So I'm going to go Leo is equal to turtle.turtle, which then creates the turtle in the center. You can then change the shape by using the dot shape function. I'm going to change that to a turtle. And then we're going to change the color to blue. Save that. And then we'll run it. Cool. So now we've got a turtle in the center of our screen. Now, what you can do is then go through and make a whole heap of comments. So then it's a lot easier for you to understand all the pieces. So there's above line comments where you can do 3 hashes on either side. So this gives me a description saying this is the code to create a turtle. And then these are called inline comments. So import the turtle. So this makes the turtle library available. This creates the turtle. And then this makes the turtle icon appear. This makes the turtle blue. And then write your code down below. Now you can go to this level if you want. I'm not expecting you to. It does make your life a lot easier if you're not quite sure of what's happening. But usually what happens is you try and write the code so it's pretty obvious what you're trying to do. So as you get better at programming, the need to write comments for everything sort of starts dwindling away. Okay, so basically what happens here is when I write the code, usually I would leave that because that code's pretty self-explanatory because it says the shape is the turtle, the color is blue. And then underneath here, I would write the code below. So what we're going to do now is we're going to write this comment here. Find it again. And we're going to have the comment 1, 2, 3. Write your code below here. 1, 2, 3. And then now we're going to make Leo go forward 100 pixels. So I'm going to save that. And then I'm going to go up here to run. Now you should have seen that went across 100 pixels. Cool. So then the next thing that you can do then is rotate the turtle 120 degrees to the left and then move the pixel 100 pixels forward. So this is pretty easy. We're just going to add another line of code in our movement code. So here we're going to go Leo.left and we want him to go 120 pixels. Let's run that. Cool. Done. So the first challenge I want you guys to have a crack at is trying to make the turtle so it makes a little square with sides 200 pixels long. So just pause the video and we'll come back to it. Awesome. So this is pretty much what you should have done. So you can use the original movement code that we had. What you should see in here is we're just going to change some of this a little bit around. So because we want to go 200 pixels, we're going to change this bit here to now say 200. And then we're going to go Leo.left 90 degrees. And then because I'm lazy, Command C. I'm going to run that. And there's our cool little turtle that's made a little square. Awesome. So hopefully that made some sense. So the colors in total, there's a whole heap of different ways of doing it. So there's not just the way that we've done there where we've used the keyword blue. You can use any of these keywords. So violet, plum, sky blue, light blue, all these words are available. I think there was over 60, I think, from memory. So you can use the named color. So if we wanted to use lime, you could just use that. You could then use the hex code, which is what we've talked about before. So 00FF00. So this is how much red, how much green, and then how much blue, which gives you the lime color. Or you can type in the RGB values. So basically RGB represents from 0 to 255. And that should be familiar because each one of these represents a byte. So there's 3 bytes inside of a color. And oh, there you go. There's 139 colors to choose from this grid that you can use. So you can use name colors, the hex code, or the RGB value. Now the way that you do that is what we've done here. So you just literally go leo.color, and then you can change the color around to whatever you would like. You then change with the hash code, which gives you the hex code. So by putting a hash out the front inside the quotation marks, will then not make it a comment, but actually make it a color. You then also use the color mode, but you will need to change it first. So by going turtle.color mode 255, and then leo.color brackets 0, 255, 0 would then set it to that number. So we're going to have a little challenge here. Try and move the an orange turtle so it creates a triangle with 150 pixels long. Just pause the video, have a go. Awesome. So let's have a go here. So the first thing is we want to change the color to orange. So up here in the color, we're going to change that to orange. And then now we want to go 150 pixels. So we're going to go leo.forward 150, leo.left 120. And again, because I'm lazy, Command C, Command B, Command B. Save that. So you can either press Command S or go down here to save and then run the module. Cool. So the other thing that you can do, it's possible to color in a whole polygon. So at the moment, inside the shape hasn't been filled in. And the way that you do this is by using the fill color and the end color. So it's possible to fill in the color of any enclosed shape by setting the fill color by telling the turtle to begin a fill and then to end the fill. So these are 3 lines of code are used. So the turtle.fill color, you set that to the red, and then turtle.begin fill, then you move around and then make sure that it encloses so it comes back to where it started, and then use the end fill command. Cool. So third challenge, have a go now to see if you can move the turtle to create a red filled hexagon with sides 100 pixels long, and see if you can hide the turtle at the end as well. So just pause the video and have a go. Awesome. So this is basically what your code should look like. So I'm going to get rid of this. I'm going to change the shape of Leo as well. So I'm going to get rid of that. I'm going to use the fill color for Leo. So I'm going to go leo.fill color red. And then leo.begin fill. So then it knows that the shape is going to be filled in. Now Leo goes forward 180 pixels this time. And then Leo, because it's a hexagon, it needs to turn 60 degrees 6 times. And the easiest way of doing that is if there's 360 degrees in a shape, you divide it by how many sides there are, which is a bit of math. So now, again, because I'm lazy, I'm going to do a copy paste job. And then leo.end with fill. Let's run that and see what happens. Oh, done. So hopefully that's giving you some ideas of what you can do in total. There's a lot you can do. So these are the 4 commands that we sort of drew on originally. So forwards, backwards, left, and right. There are a whole heap of as well. So you can also do up and down, which then moves the turtle around without lifting the pen, and then puts the pen back down if you want. You can then change the color, which is what we've done. We can set the fill color. You can do the begin and end fill, and then there's also the stamp command, which leaves a copy of the turtle randomly along. There's a whole heap of different commands in here. So if you click on this library, you'll see this diagram. This comes up here, and it gives you all the different commands that are available to you, which is there's a whole heap there that you can play with, which is pretty cool. So some conclusion questions to think about: how today's graphic skills can be applied to future programming programs, and then reflect on how the Python programming is relevant for your future careers and interests. So if you're interested in graphics and movement and using a bit of code to do that, this is definitely the way for you. And then thinking about some real world applications where Python and Turtle graphics might be useful. There is a code that you can play around with, which is super useful. And then there is also this link to Turtle, the trace of the turtle, which is really, really handy. This is, I think, was done by Evelyn Hunter. Yeah. And she's gone through and given some awesome examples to go through with how to learn all this. Highly, highly recommend. So hopefully that's helped giving you some ideas of how to do Turtle and playing around with it. The more you play around with this, the better it becomes. So my advice with this is just getting in, play around, try and build your name, have a go at the homework that I've sort of attached there, and hopefully you've enjoyed. So if you have, please give us a like and subscribe down below, as it does help with the YouTube algorithm. And yeah, thank you very much. See you next time on Steam with Steve. Adios.